All right, we continue with then. So section C, we're just going to fill in the values that we found. So if you've already done that, if not, you can go back and just look them up. All right, so part 3 is about some identities. That means some relationships that, some of which we've noted. The first one, we've already noted that there are reciprocal identities. So cosine A is the reciprocal of secant, right? Which means cosine A is 1 over secant, or the reciprocal of. Of course, secant is the reciprocal of cosine. Cosine is the reciprocal of secant. Same thing with sine and cosecant, and the same thing with tangent and cotangent, right? Each of those is a reciprocal pair. There are also something called quotient identities, and that is the tangent and the cotangent, right? So the tangent is sine over cosine, and the cotangent is cosine over sine. All right. And then finally, we have what are called the cofunction identities, and they're listed there. So let's look at sine A is cosine of the quantity 90 minus A. And of course, that results because you're just looking at the other part of the triangle. If you think about a triangle, like the 30, 60, 90 that we saw. So when you look at the sine of 30 should be the cosine of 90 minus 30, which is cosine of 60. And of course, absolutely, the reason why that happens is because you only have two acute angles on a right triangle. So the opposite side of one angle is the adjacent side of the other angle. So if we think about the 30, 60, 90 triangle, the side opposite 30 is the side adjacent to 60. Okay? And so that's what happens there. And notice it's that the other angle, because we have one right angle and the other two angles are complementary, which means they add up to 90. Okay, so the sine of A is the cosine of 90 minus A. Whatever acute angle A is, secant of A is the cosecant of 90 minus A. Tangent of A is the cotangent of 90 minus A. Cosine of A is the sine of 90 minus A. Notice that's the same as sine of A is cosine of 90 minus A that we saw first. Cosecant of A is secant of 90 minus A. And cotangent of A is tangent of 90 minus A. All right, let's see what we have to do with these. Let us see our examples. It says, find a cofunction of another angle with the same value as the given function value. This is, letter A says, find, cosine of pi over 4 equals the square root of 2 over 2. Find a cofunction of another angle with the same value as the given function value. So we know that the cosine of pi over 4 is the square root of 2 over 2. How do we address this? Well, what is the cofunction of cosine? Cosine of A is sine of 90 minus A. But what's 90 in pies, right? Because it applies whether the measure is in degrees or in radians. Well, pi, if we think about the circle, a whole circle is 2 pi radians, half a circle is pi radians, a quarter of a circle, that's the 90 degrees, is half of a pi, or pi over 2. Okay, so that means cosine of pi over 4, I'm going to write it here, cosine of pi over 4 is the same thing as the sine of pi over 2 minus pi over 4. So I'm saying the cosine of A is the sine of 90 minus A. All right, and so cosine of pi over 4 is the square root of 2 over 2. And that is the sine of whatever pi over 2 minus pi over 4 is. And if you work it out, you'll find out that it's pi over 4. Okay? So we found that the sine of pi over 4 is also the square root of 2 over 2. Letter B, cotangent of pi over 6 is the square root of 3. And again, I would write the cofunction identity that I just saw. It says that the cotangent and the tangent are cofunctions, right? So I would say the cotangent of pi over 6 equals the tangent of, and again, because I'm dealing with radians, it'll be pi over 2 minus pi over 6. All right, I'm going to let you finish that one off. And we'll finish it in class, or we'll see it again in class. You can do it on your own if you want to, but we'll see it. Part 4 says finding trig function values using a calculator. So the first one, 22 degrees, 18 minutes. And so I got my trusty calculator out. How am I going to do this? because my calculator doesn't have minutes. So I'm going to first convert the minutes into degrees by just making it a fraction. So it's 18 out of 60. 18 divided by 60 is 0.3 degrees. Plus 22 is 22.3 degrees. And the sine of that, oh, is this in degrees? Let's check. Let me see, where do I find that? All right, so I find that if I go to modes, this is mine. So you'll have to do probably something similar on yours. And it's degrees. So you got degrees, radians, and gradients. And so I'm going to pick degrees. Okay, so it's 22.3 degrees, and I'm finding the sine. And by the way, on mine, I type in the number and then find the sine. And on yours, you might type in sine and then type in the number. All right, so I got 0.379 approximately. Says to the nearest thousand. So okay, so this is the sine of 22.3 degrees, which is about 0.379. Okay, how do I find the cosecant? Remember, cosecant of 50 is cosecant is the reciprocal of the sine. So this is 1 over sine of 50. Yeah, and so because my calculator again doesn't have cosecants, it's got sine, cosine, and tangent, then I have to do it that way. So it's sine of 50 degrees, so it's, do I have a 1 over x? No, so I'm going to have to do 1 divided by the sine of 50. So it's 1 divided by 50 sine. 1 divided by the sine of 50 is 1.305. About 1.305. Okay, and some of you might have a calculator that has one. Oh, I do have 1 over x. Let's try that again. 50 sine, I have the sine of 50, and 1 over x is 1.305. Sorry about that. I should know my own calculator. All right, and I'll let you guys take care of the other ones. Notice, oh, I should have done maybe like that one. This is sine of -2. Notice it doesn't have degrees, so that means it's radians. And so I just need to put my calculator in radian mode. There it is in radian mode. And notice it's got a little RAD. I don't know if you can see that. RAD label. It tells me it's in radian. And I'm just going to type in 2 negative. And then type in, what is it? Sine. And that gives me the sine. Negative 0.909 about. All right, I'll let you guys finish secant of 4 pi over 3. Don't forget it has to be, that's a radian measure. And so check your settings on your calculator. Okay, some applications, actually one. The angle of elevation or depression. The angle of elevation or depression from point X to point Y is the acute angle formed by ray XY and a horizontal ray with endpoint X. That means if I'm standing at the top of a building, the angle of elevation is measured from the horizontal down to look down. The angle of depression. And if I'm at the bottom of the building and looking up at the top, the angle of elevation is measured from the horizontal straight ahead upward to the top of the building. All right, let's try an example number 1. The angle of depression from the top edge of a 112-foot building to a point on the ground is 12 degrees. How far is the point from the base of the building? So I'm going to draw a picture. I'm going to draw a right triangle with the height of the building on the left, and then the horizontal distance, the bottom to that point that I'm looking at. And then I'm going to connect the two sides to form a right triangle. Okay, so my height of the building is 112. That's on the left leg there. The angle is 12 degrees. 12 degrees. The angle of depression, is measured from the top to the bottom. So it's 12 degrees looking downward. But if you know the relationship between angles, because if I look at from the top of the building straight across, that's parallel to the bottom of the building straight across. And so that 12-degree angles is also the 12-degree angle at the right end of that triangle that I drew. Okay? All right, and the distance that I need to know is how far is the point from the base of the building, which is just the base of my triangle. I'm going to call it x. All right, so how do I approach this? Well, I know the relationship between these three numbers. I know that the tangent of 12 degrees is opposite over adjacent, which is 1/12 over x. So I'm going to write that down. I'm going to say tangent of 12 degrees is equal to 112 over x. And these are feet, right? So x is going to be in feet. All right. And I can solve for x by multiplying both sides by x first. So I'll have x times tangent of 12 degrees equals 112 feet.